Dear students, I welcome you all for this video lecture on memory allocation for objects. Actually, we had these topics under problem solving using C++. In this video lecture, actually what we are going to discuss is, in the last class we had discussed regards classes and objects. While creating objects, how the memories are allocated for objects. Right, we know that while if we want to access any class members, we should create objects. For example, the class may have some data members or member functions and so on, etc. Some properties it may has. If we want to access any data members from the class, we should have objects. Without object we cannot access the class members. So for that, we can, for a class we can create a number of objects. Like if we are creating a number of objects, how the memories are allocated for that object. That's actually we are going to discuss in this video lecture. So before going to discuss this, I introduce myself. I'm Shankar. I'm working as assistant professor in the Department of Computer Science and Engineering at RMD Engineering College, Chennai. So let's go to the video lecture regards our topic, how we are allocating memory for the objects. So let us see. Today topic is memory allocation for object. So let us see few points how the memories are allocated for the object. Before using a member of a class, it is necessary to allocate the required memory space to that member. The way the memory space for data members and member functions allocated in different, regardless of the fact that both data members and member functions belongs to the same class. It means that before using a member of the class, if you are creating some members, so you should allocate a memory. The same way, the memory space for data members and member functions. We know that what is data member and what is member functions, right? So data members in the sense, the variables which we have declared under the class, we can call it as data members. If we are defining some functions inside the class, we called it as member functions. So the way we are allocating the memory space for the data members or member functions is allocated in different, regardless of the fact that both data members and member functions belongs to the same class. It means that whatever we are discussing for allocating a memory, so for data members and member functions, both must be a member of the same class, right? And the memory space is allocated to the data members of a class only when the object of the class is declared. You just see once again, the memory space is allocated to the data members. The memory space is allocated to the data members of a class only when an object of the class is declared, right? When the object of the class is declared, and not when the data members are declared inside the class. It means that if you have, right, like you are declaring a class, once again, you are declaring a class and you have class name, right? You have open parenthesis, close parenthesis. The close parenthesis ends with a semicolon. This is the general syntax for declaring a class, right? You are declaring some data member, whether it is private or protected or public, that doesn't matter. For example, int. For example, int a is one data member. So what we are talking is, if we are creating object for the class name, how the data member int a can take memory space in the class, right? That's actually we are discussing. So the memory space is allocated for the data members of the class, what you are declared inside the class, is only when object of the class is declared. For example, if you declare look like this a class, a will not take any memory space while declaring inside the class. When it takes memory space in the sense, we want to create a object, for example, class name, object name, object name, right? Class name, also this is o1 in the sense object one. So when you are creating object O1, then only the memory space for A is created. That is actually given. You just see once again, the memory space is allocated to the data members of a class only when an object of the class is declared, and not when data members are declared inside the class. You just see when the data members are declared inside the class, this time will not create any memory space for the data member. When you are creating object for the class, then only it creates memory space for the data members, right? That is the point. And next, since a single data member can have different values. For example, previously you have declared A. A may take value 10 one point of a time while executing a program. At later some point of a time, A again may have 50. Some point of later, A again may have 100 or 101 and so on. So single data member can have different values for different object at the same time. It means that what I said here, I have declared object called O1, maybe O2, O3, O4 and so on. So while accessing O1, I may give value for the A is 10. While I'm using O2, I may give value for A is 100. While O3, my value of A is 17. So what happened? Three different values it hold based on the object. That's the point is here, right? So since a single data member can have different values for different objects at the same time, every object declared for the class has an individual copy of all the data members. On the other hand, the memory space for the for the member function is allocated only once, right? When the class is defined, it means that suppose if you are defining any member function inside the class, that time itself your memory space is allocated. And other words, there is only a single copy of each member function which is shared among all the objects. Let us see. We'll see once again. For instance, three objects are there, right? Namely, the object name 1 is book 1, object name 2 is book 2, object name 3 is book 3, right? The class name is book. We have a class called book, right? Class, class name is book, right? So if you have something data members inside the class, you have created three objects called the book 1, book 2, book 3, right? For book class. So it has three individual copies of data members. For book 1, you have individual copy of data members. For book 2, you have individual copy of data members. For book 3, you have individual copy of data members, right? So the data members are title and price, right? The book contains two data members. One is title and another one is price, right? There are two data members are there in the class called book. So for book 1 have individual copy of title and price, book 2 have individual copy of title and price, and book 3 have individual copy of title and price. Okay. So what's happened? What about member function? Because previous what we have discussed, this is called actually data members, right? This is data members, title and price. So now we have member function called get data and put data. What happened here is while declaring the member functions get data and put data inside the class, whenever you are defining or declaring, that time itself common copy of memory space is created for get data and put data. So what happened here? Book 1 shares same memory space, book 2 shares same memory space, and book 3 shares same memory space. But for title and price, it is not like that. Separate memory space for book 1, separate memory space for book 2, separate memory for book 3. For what? Data members, title and price. But for member function, get data and put data, while declaring or defining inside the class itself, it creates a common copy for the member functions and it shares all the objects for the same memory space, right? Yes, I hope you understood. Yes, so you just see we have a class called book. Our class name is called book. For book, I have created object called book 1, object called book 2, object called book 3. So I have totally three objects, book 1, book 2, book 3, right? If I'm declaring any data members, so as of this example, I have declared two data members, that is title and price, right? See, the book 1 have separate individual copy of title, separate individual copy of price, right? So when this memory space is created in the sense for title and price, when you are creating object book 1, that time this memory space is created. If you are creating object called book 2, again one more memory space for title and price is created. Suppose if create another object called book 3, again it creates another memory space for title, price. So this is different memory space, this is different memory space, this is different memory space. You just see here, uh, the memory space is allocated to the data members of a class only when object of the class is declared, and not when the data members are declared inside the class, right? Also, these are all different, right? The single data member can have different values for the different object at the same time. Every object declared for the class has individual copy of all the data members, right? Every object, this point you should remember, every object declared for the class has individual copy of all the data members. So what are the every object? Object 1 is big 1, object 2 is book 2, and object 3 is book 3. For every object, it creates individual copy of memory space. But you just see here, for member function, what happened? It has common memory area. While you are declaring, once you defined any function inside the class, common copy is created for get data and put data, that is member functions. This memory function is shared among all the objects for book 1, book 2, book 3. For book 1, book 2, book 3. For book 1, book 2, book 3. Right? So the common memory space is shared among all the objects. So what you remember, for memory allocation for any class, right? For the data members, it allocates individual copy of memory space for the of every objects. But for member function, it is not individual copy; it is common copy for all the objects, right? Yes. I hope you understood about the lecture, how we are allocating memory for the data members and member functions. Uh, I thank you all for watching this wonderful video lecture series so far. Thank you.